I. So now let us see fourth application, that is finding irreducible set. So as name implies, reducible, and here it is actually irreducible. So let us see, further reducing is not possible. Simply its meaning is. So let us see what does it mean. A minimal cover of the set of functional dependencies F is a set of FDs G such that every dependency of F is in the closure of G actually. So that is actually every dependency of F can be determined by using G. So that is what previously we discussed already. Equivalence actually. F covers G, G covers F. So in this case, a minimal cover of set of functional F is actually covering actual set G actually. So here G is calling a minimal set or irreducible set actually. So this statement is going to clear very much when once we see the example actually. So here if you see the procedure, how to find the irreducible set. So the step one is write a given set of functional dependencies in a such a way that each functional dependency contains exactly one attribute on its right hand side. So for example, just for understanding sake, if you have x derives CAP, then what we are doing is from this x derives A and x derives B. By using decomposition rule, we can write down like this, right? That is what actually he is saying. RHS side, exactly one attribute must be there. Here two attributes, so we divided like this. Like that, how many attributes you have RHS side, that many FDs individually, you please try to write down. And then what we have to do after that? So step 2, determine each FD one by one, whether it is essential or not. So here you see, if I find X closer by having this and by not having this, so that is what, once by considering FD present in the set. So this particular FD, if I take, if this FD consider and find the X closer, and once by considering FD not present in it actually. So without considering this FD one actually, by having this in the set of FDs, by not having in the set of FDs, so both if they are giving same result, then eliminate this FD actually. X to A we are going to eliminate from the set. If both are not same, this is essential. So that is what, whether it is essential or not. When it will become essential, if both results are not same. So this is going to become very simple when you are discussing example actually. Immediately after this we will see. So like this, every FD we are going to cross check whether it is required or not. That means whether it is essential, mandatory or not in the set. We will try to decide from this step 2 actually. Then step 3, see actually x to y if you take, where x is a set of attributes, y is a set of attributes. So this is RHS part. If you take, this is LHS part. For the RHS part, we are going to do step 2. Now in the step 3, we are going to do for LHS part. So that is what, check if there any functional dependency that contains more than one attribute on its left side. For example, now AB deriving X. Just opposite to this step 2 we are doing in step 3 actually, nothing is there. So you can see here what he told, contains more than one attribute. Yes, so you have more than one attribute, LHS side. So at that time what we have to do? So for example, I'm going to take B. So A derives X like this I'm going to take. Am I able to get the same result without B also? So with without B with B, for example, if both the results are same, B is not required in the FD actually, in the LHS part. Is it or not? So that is what, for example, two persons are there in one day they are getting the profit 10 rupees. And three persons are there next day, same 10 rupees they are getting. So by adding extra person, their result is not result is same actually. That means that the third person no, not required actually. So that is why you can skip that third person. So same thing here also. Two attributes are there. By having B, by not having B, if you are able to generate the same result, that means B is not affecting anything actually. B contribution is nothing. So you can skip that actually. Same way we will cross check for A also. So without A, with A, if you are getting same result or not, we will observe. So that is what compute the closure of all possible subsets of left hand side, all possible sets. So A is one subset, B is one subset, AB is another subset. Then if any subsets produce the same closure, result as produced by the entire left side, whatever result you have earlier, any one of the subset, if any subset produce the same result, then replace the left side with that subset actually. So for example, in this case, A is giving the same result, but here B is giving different results also. So because A and AB, both of them, if this is existing one and new subset A, if both of them giving same result, then this thing we are going to replace with A to X. That is what. Then replace left hand side with this subset. That is what EA. Now onwards, for the next steps, we are going to have this FD actually. So these things, whether you understand or not, just keep it in mind. Once we solve the one simple example, if you come back to the same steps, this is going to become very simple. Okay.